Okay. By now, if you have not subscribed, you are not praying for us. Let's defeat the YouTube algorithm by you subscribing, liking, and commenting on this video. That is the only thing I require to be motivated to do this. Okay, now, one of the most, should I call it, more confusing parts of signals, of classifying signals, is always power and energy signals. In summary, because I don't want to go into details, if you want to get a power signal, we only have a power signal if after getting this, if the power signal on integrating it, having the square of that function and integrate it within the time period, within the period given, which might be t to 0 or sometimes t over 2 to minus t over 2, and you take its limit to infinity, and yet you get a value which is within this boundary, 0 less than p less than infinity, where p is the value of the power signal, and your e trying to do the energy content, trying to get the energy content of that signal, you get infinity. That signal can be explicitly be classified as what? As a power signal. In another way, energy signal are signals that when you get the energy content of that signal, the value lies in within 0 is less than e is less than what? Infinity. That is, the value is actually real. So, and your p on calculating for your p, you get p to be equals to 0. Then you have what? An energy signal. This is the condition for classifying a power signal and an energy signal. In a bit, I'm going to write down the formula for calculating that will be used to classify our power signal and energy signal, and we'll do some examples on it. Mind you, don't just watch this video. Like, comment, subscribe. Don't just download. Like, comment, and subscribe. Okay, right back. Now, as I promised, I'm going to be writing the energy equation, energy formula for calculating for classifying whether it's an energy signal or it's a power signal. You remember when I was classifying signal for you? I told you we have discrete signal and we also have a continuous time signal. Now, when you are given a discrete signal, and you want to classify whether it's an energy signal, you use this formula: infinity to minus infinity xn x of n squared. You can see the bracket here, the parentheses you have here actually shows that it's what is a discrete signal. Now, the parentheses you have here actually shows that this is a continuous time signal. So when you have a continuous time signal, you want to test for its energy, you want to classify whether it's an energy signal, you use this. So it's either this, which is for continuous, or this, which is for what? Which is for discrete time signal. And the same way also goes to what? Power signal. Power signal, if it is continuous signal, you use limit as t tends to infinity 1 over t over 2 minus 2 over the whole formula, and this is also for discrete. This is for discrete, and this is for continuous time signal. If you want to classify it as what? Power signal. You want to classify it as power signal. Now, let me tell you this. If don't mind all these formulas that are going down here, and here is the problems we are going to be using this. We are going to be applying this formula to solve this problem. Now, a quick recap of a quick advice is this. If you've forgotten limit of a function, or you've forgotten how to get the limit of, or how to integrate, I would advise you to pick up any engineering mathematics textbook or any mathematics textbook of your choice. Try and revise this, because we are actually going to be using this in this video to explain and classify signals, whether they are power signal or energy signal, or whether they are none. Because there are some signals you will not get a positive, you will not get a value, a real value for power signal, the real value when you even test them as an energy signal. Those signals are classified as they are neither a power signal or an energy signal. So now let's get the work done. Now, the first problem, I will solve the first problem. The first problem, we are giving x of t to be equals to a cos into bracket w of t omega t plus theta 9. We want to classify whether this signal is actually an energy signal or a power signal. Now, the first step is, why don't we start with energy signal? Since this is a continuous time signal, you can actually say our E is equal to integral, according to the formula that I just gave us, integral x of t, then we find out the square of the absolute. So we move on to integral minus infinity to minus infinity. Then substitute this whole thing there. You have a cos bracket omega t plus theta close bracket, then everything squared. Then you have the t, the t, you will have the t at the back. Now from here you can have integral infinity minus infinity. Then I have a squared cos squared bracket omega t plus theta dt. Now looking at this, I can actually, since a squared is going to be, it can be treated as a constant, I can bring this a squared to the back, right? So it is good if I say this is going to be what? A squared integral what? Integral cos squared w naught of t plus theta dt. Now this is within the boundary of minus, integrating from minus infinity to infinity. Now remember that from basic trigonometrical ratio we have it as cos squared theta is the same thing as what? Cos squared theta is cos 2 theta plus 1 over 2. Now if we have this, we can actually now say our cos squared bracket omega naught of t plus theta is the same thing as we having cos into cos bracket, I can say cos bracket 2 bracket w naught of t plus theta plus 1. Sorry, let me find the way to accommodate this. My cos squared bracket goes to omega naught of t plus theta is equals to cos 2 into bracket omega naught of t plus theta plus 1 over 2. Now I can substitute this expression into this back and add this to be equals to a squared integral infinity minus infinity. Then I add this to be cos bracket cos 2 bracket omega naught of t plus theta plus 1 over 2. Now dt plus, let me say plus 1 dt plus 1 over 2 dt. Now we have this. Now you know I can actually integrate this and say this is going to be a squared. Integrating this, you are integrate this cos 2 omega t plus theta. Now if I integrate with respect to theta, what I'm going to have here is going to be, or I should split it. Infinity minus infinity cos 2 into bracket omega naught of t plus theta over 2 plus 1 over 2 close bracket open bracket dt. Now from here I will continue here and I will say this is going to be a squared. This is going to be equal to a squared integral infinity minus infinity. Now this is going to be cos 2 into bracket omega naught of t plus theta. I'm just writing it so that you will see it broadly all over 1 over 2 open bracket close bracket dt. Now we have a squared integral infinity to minus infinity, and we have this. We have the whole expression between here. Now if you integrate cos, what you are going to get is sine. So we have a squared sine of 2 into bracket omega naught of t plus theta over 2 into bracket 2 omega naught of t plus t over 2. This is going to be infinity minus infinity. So from here, if we substitute this, what we are going to get, what we are likely going to get at the end of everything is going to be that our E is what? Is itself infinity. So from the condition that we have, what this is actually telling us is that this is not an energy signal because it is not specified, it is not real. What we have is, our answer is infinity. So we can actually suspect that this is quite going to be a periodic signal, and if we test for we do periodic signal test for this, and yet we didn't get any value, then that means we can classify this signal as neither a periodic signal or an energy signal. But let's try and do a test on periodic signal and DC signal. Now we'll continue from there and we'll have the limit as t is tending to infinity. Rather than this, why don't we have a squared multiplied by a squared, then let 1 over t multiply through. If 1 over t multiply all these things, we have sine into bracket 2 into bracket w dot of t plus theta bracket, and I'm going to have 2 into 2 multiplied by this will be 2 multiplied by 2 multiplied by 2 pi over t multiplied again by 1 over t multiplied again by 1 over t. Now multiply again by not 1 over t, multiply again by t because this is 1 over t already. Now t plus sine 2 theta over 4 multiplied by 2 pi over t multiplied by t again. Then we can now add this to the also plus t, this is going to be minus, then this is going to be t over 2 multiplied by t again. Now by the time we do all of this, we should end up with what? We should end up with a squared over 2, because this actually will let this go, then this will actually will let this go, and this is going to be like 1 over t to this, and this will actually let this go. Then we are left with the 1 over 2 that is left here is going, now we will be left with a squared over 2 as our answer. Yeah, by the time we put c is equal to infinity, wherever we see t again, we will put it as infinity, it will become 0. But sine of infinity is actually sine of 90 is 1, then sine of infinity is 4 times 0, you add this as a squared over 2. And this actually shows that our final answer is going to be a squared over 2. This actually shows that this is actually a periodic signal. For A, now if for A is real, if A is real, if for A is a real number, a real value function, then that simply means that this is what? This is actually A. You can conclude and say therefore x of t equals A cos into bracket omega naught of t plus theta is a periodic function. Now, we're doing the second example. Let's see whether it's a power signal or an energy signal, or it's neither. Now, let's move on. This is going to be very, very easy. So now, I can say, let's test for energy signal. If we test for energy signal, we have infinity minus infinity, c u of t, everything squared. Now, if we do this, what we're going to have is infinity minus infinity, then I have t squared u of t dt. Sorry, I'm always forgetting this dt. Now, this u of t, we turn this minus infinity to what? To 0. Because we know that u of t is 1 when t is greater than or equals to 0. And it is 0 otherwise. So, if this u of t is at the back of this t, then that simply means it's going to be 0. It's going to be 0 for any past values. For any past values, the whole thing is going to be what? It's going to be 0. Which reduce this to what? Integral infinity 0, then t squared dt. Then we can move on to get this as 2. If I move on to this place, then I have this is going to be what? T raised to 3 over 3 bracket what? Infinity minus 0. Hence, what is going to happen is infinity t over 3 minus 0, which is the same thing as infinity. Hence, this is not what? Hence, t u of t is not an energy signal. Now, let's try getting the power signal for it. Now, I will use the formula that I gave you initially, which is going to be what? Limit as t tends to infinity, then we add this to what? 1 over t integral t over 2 minus t over 2. I told you can use any of the two, x of t squared dt. So here I'm going to have limit t is tending to infinity, 1 over t. Let me substitute my x of t, which is t u of t integral t over 2 minus t over 2. This is t u of t everything squared dt, which is that t over 2 minus t over 2 t squared u of t dt. In this case, the same thing. In this case, we are still having u of t in this case. Then I can turn this just to 1. Now I can move on to this and say this is going to be limit as t tends to infinity. 1 over t integral t over 2 minus t over 2, then t squared dt. Now try this without limit t tends to infinity. 1 over t, then I have t over 3 close bracket, t over 3 close bracket, then I have t over 2 minus t over 2. So I am left with what? Limit as t tends to infinity of as t tends to infinity, then I have 1 over t multiplied by what? T over 2 raised to 3 over 3 minus bracket minus t over 2 raised to 3 over 3 close bracket. This is going to be limit t tends to infinity of 1 over t into bracket. This is going to be t over 8 divided by 3 minus. This is going to be minus t divided by 8 over 3. Then this divided by 3 divided by 8, t divided by 8 over 3. This we have minus and minus here will give us a plus. So we can as well write this as well a plus. Limit t tends to infinity. Then we can say 1 over t multiplied by this is going to be 2t over 8 over 3. Then this is going to be limit t tends to infinity 1 over t. Then I have this as bracket t over 4 times 3, which is going to give me limit of t tends to infinity of t squared over what? Over 12. And finally, this is going to be infinity again. So that simply now means that since I got infinity for energy when trying to classify it as energy, when trying to do an energy classification test for it, and for periodic also I get infinity, that simply means this signal is this signal cannot be classified as an energy signal, nor can it be classified as a power signal. Okay, this is the last problem we're solving, and if you have not liked, no, you have not commented, and you have not subscribed to this channel, you are not encouraging this channel at all. So one prayer you can give to this channel is you like, you comment, and you subscribe. That will be going to defeat YouTube algorithm. So now let's go into this question. This is actually going to be very similar. To get the energy content of a signal, which is for a discrete signal, you actually need the sigma infinity from n is equal to minus infinity to infinity of x of n, everything squared. Now, this is what we are going to do. Infinity, sum to infinity of n from minus infinity, sum to minus from minus infinity to infinity. Then put it all around. Then let's put our function minus 0.5 everything raised to our n squared u of n. Now this is going to be infinity n from minus infinity to infinity of minus 0.5 is going to give us 0.25. Then u of n. Now this u of n, I've told you this is what this is telling us. This is going to be 1 when n is greater than or equals to 0, and it's going to be 0 otherwise. So hence it reduces this minus infinity to what? To 0. So this whole content, this whole boundary which is showing bilateral, which is showing it as a bilateral function, is now reduced to a bilateral function. This is now going to be infinity, n is equal to 0 of 0.25, n is here, n is here. Now, if you look at this, this is like sum to infinity. Now, from basic mathematics, or pre-calculus, we believe that our sum to infinity is actually our first term over what? 1 minus what? Common ratio. So we are about to use this formula to get get this. So we can actually say our A in this is, if we test this function, let's say we test this function x of n, let's call it x a of n equals, let x a of n equals 0.25 raised to power n. So that if we test this, x a at 1 is going to go 0.25, then x a at 2 is going to be 0.25 raised to power 2, and it will continue like that. Hence, this is showing us that this, for our first term, is going to be 0.25, and our common ratio is going to be 0.25 as well. So we can actually now write this as sum to infinity as what is a? Our a is 0.25 over 1 minus 0.25. 0.25 is like 1 over 4. So we can say 1 over 4 over 3 over 4. This causes this, hence we have 1 over 3. 1 over 3 is real. That simply means this is actually an energy signal. And since it's an energy signal, I think we can stop here. We don't need to test. Since we have gotten real value for energy signal, it cannot be both at the same time. A signal cannot be both at the same time. It's either it is energy or it is power. So we can actually conclude that X, capital letter N, is an energy signal. Or in another term, we can say that X of N is actually has an energy content. So lastly, if you have not yet subscribed, I really don't know what you are doing right now on this channel. You should subscribe, like, and comment. That is equivalent to a prayer for the YouTube channel.